So with this video, we're going to go through a little bit more challenging exponential equations than we did in class. In class, pretty much so far, we've only done like something like 3 to the x equals 27, right? You know the answer is going to be 3. Right? You're looking for the exponent. Or even a little more challenging, 3 to the x equals 1/27th, and you should recall the rule of negative exponents. The answer would be -3. So these problems are a little bit easy when you know what power of this number this answer is equal to, right? But I wish I had an eraser. Okay, but these are a little more challenging. All right, so just watch me do a few of these, and you'll be able to do a few at home. That's the goal. So it's going to be very helpful if you remember, your powers. That's why I'm having you sort of memorize the basic ones. So the first step, guys, to do any of these problems, because none of them have the same base, the big number, none of them are the same, you've got to make them be the same. So we have 5 to the power x minus 1, and we can write 125 as the power of 5. 5 to the third. So you've got to know that. You've got to know that 5 to the third is 125. Okay? We didn't need to change this side because I knew that we could write this number with a base of 5. Right? You want to have the same exact big numbers, the same bases on both sides. Because once you have that, just ask yourself, if 5 to this equals 5 to that, then those must be equal, right? So we can now just set an equation up that just drops the 5's out of the picture. X minus 1 equals 3. Now, what we're doing to both sides of this, technically, we're taking the logarithm of both sides. The inverse of exponentiation is take the logarithm. You don't need to show that step, all right? You should just kind of understand that 5 to this equals 5 to that. So then once you have the exact same base on both sides, these numbers have to be the same. Then you can just set the exponents equal, add 1, and we're done. X equals 4. And to check our work, we can plug in 4. 5 to the power 4 minus 1. 5 to the power 4 minus 1 equals 125. Yeah, that's true. 5 to the third equals 125. That's true, right? So that's the first one. Okay, just you want to get, again, in all these problems, get the same base on both sides, and then set the exponents equal. Those are the steps, all right? Next one, 64 and 4. We've got options here. Guys, we can write both sides with a base of 2, because both 4 and 64 are powers of 2, as you guys probably know. But it's going to be a little bit easier if we can write the other side with a power of this number. It's going to be easier just to do that. Let's use a base of 4. So this side I'll just keep as 4 to the x plus 2. 64 you should know is 4 to the third. Now I want to put parentheses around this when we substitute it, because if it was more than just x, we would need to distribute that exponent to both terms. All right? In this case it doesn't really matter. But here, guys, we get 4 to the we multiply exponents. Right here, when you have a power raised to a power, just stuck outside the parentheses, we multiply 3 times x, not 3 plus x, equals 4 to the x plus 2. Hope you guys can see that okay. I know it's a little bit scrunched. Ignore this problem. Again, once you have the same base on both sides, you then just set the exponents equal. 3x equals x plus 2. Taking away x, we get 2x equals 2, so x equals 1. And we can plug that in. 64 to the first equals 4 to the 1 plus 2, 4 to the third. 64 to the first equals 4 to the third. That's true. All right, let me rope this off. So that was one problem. Now problem 27 here. Similar idea. We want to write both sides with the same base. Here you only really have one option. You have a 2 as the base. 8 can be written with the power of 2. 2 to the third, right? So we have 2 to the third to the 2x equals 2 to the 2x plus 2. A lot of 2's. Multiply here. 3 times 2x, you get 6x. So 2 to the 6x is 2 to the 2x plus 2. Now, again, that we have the exact same number, the same base, we'll set the exponents equal. And it's an easy problem to solve. 6x, equal sign. 6x equals 2x plus 2. Take away 2x, you get 4x equals 2. And divide by 4, right? So I'll do it a little slower. 4x, we take away 2x, equals 2. Divide by 4. 2 divided by 4 is 1/2. Okay? Be careful with that. It's not 2, it's 1/2. We're dividing by, you're always dividing by the x coefficient. Can you guys even see that? No, you couldn't. Right? So 4x equals 2, we divide by 4. 2 divided by 4 reduces to 1/2, all right? And we can plug in 1/2 if we want, but let's not for time purposes, okay? Up here, again, just like with problem 25, we have a similar situation. We can write both sides with a base of 2 or with a base of 4. It's easier to use the 4. Why change this number if we don't have to? So let's leave this as 4 to the x minus 3 power equals, this becomes 4 squared, right? 16 is 4 squared. Can I have room up here? Sort of. Multiplying, right? We have to multiply. This is why it's kind of important to use parentheses here when you substitute. 4 squared to the x minus 3 power. 2 times the quantity x minus 3 is going to become 2x minus 6. You do have to distribute, all right? So we have 4 to the 2x minus 6. Am I still on there? Just barely. 4 to the 2x minus 6 equals 4 to the x minus 3. Now we set the exponents equal. Now that we have the same base, set the exponents equal. 2x minus 6 equals x minus 3. And we can take away x. So we get x and add the 6. And we get x equals 3. Okay? So the answer to 29 is x equals 3. And we can plug that in just to check. 16 to the 3 minus 3. 16 to the 0 equals 4 to the 3 minus 3. 16 to the 0 equals 4 to the 0. That's true, because they're both equal to 1, right? Anything to the 0 power is 1. So we plug this in, we get 1 equals 1. That's true. 33, we got a fraction here. Okay, we don't want to use fractional bases. It's easier to use whole number bases. So what I would recommend you do is write both sides with a base of 2. Right, so 1/2 is 2 to the negative 1. 8 is 2 to the positive third. And now, again, we multiply the exponents. Negative 1 times x. So we get 2 to the negative x. And then we have to distribute the 3. So we get 2 to the 6 minus 3x. And now, because we have the same base on both sides, yet again, you set the exponents equal. Negative x equals 6 minus 3x. All right. Now we add the 3x over, so we get negative x plus 3x is 2x, and then we'll be dividing by 2. 6 divided by 2 is 3. So we get x equals 3. Okay? And we can check the work real fast on that one. 1/2 to the third. 1/2 to the third is 1/8. And then 8 to the 2 minus 3 becomes 8 to the negative 1, which is also 1/8. Or we get 1/8 equals 1/8, so it works out. Last, same kind of idea. Here you have a 1/3 and a 9. You want to write both sides with a base of 3. So I'll do 3 to the negative first for the 1/3. And of course 3 to the second for 9. Remember, for all these problems, that should be the first goal, is to get both sides with the same big base. All right? Now, multiplying this through, got to be careful. Distribute, we get 3 to the negative 1 times 1 is negative 1. Negative 1 times negative x, whoops. 3 to the negative 1, and the negative 1 times negative x is plus x, equals 3 to the 2x. And now, again, we have the same base on both sides. Negative 1 plus x equals 2x. You guys see that? And if we just take away the x, we will get x equals negative 1. Right, and we can check that work if we want. 1/3, 1 minus negative 1. 1 minus negative 1 is 2, right? So 1/3 to the second is 1/9. And here, 9 to the negative 1 is also 1/9. So it checks out. All right? So just a few problems to get you guys started. Wow. All right? All the problems on this sheet kind of work out the same way. You get common base on both sides, and then set the exponents equal. Just be careful with your distributing and your signs, and you're solving the basic linear equations. All right? Thanks.